Hey there. So hopefully you are checking your homework with the key. The most important thing is that you keep these three formulas straight. Our slope is always going to be the change in our y coordinates compared to the change in our x. We're looking at measuring how much my output changes compared to how much my input changes. So for each of these ordered pairs, the biggest mistakes is sometimes kids mix up their x and y's. Sometimes we talk about it being easier to make sure that your y's end up on top if you want to use the slope snake. So 12 minus negative 4 becomes 12 plus 4. And then negative 2 minus 5 becomes negative 7. So with each of these, we want to make sure that we're careful about 7 minus 5, negative 3 minus 0. We want to make sure we're careful with 0 minus 8 and 5 minus negative 4. That's where that plus sign comes into play. Now when we talk about the midpoint, our midpoint is always going to be the average of the coordinates. So my midpoint, I'm going to be adding my x's, adding my y's together, and then dividing by 2. So simplifying fractions where I can and where I need to. That's how we get our midpoint. Our distance formula, again, comes from Pythagoras because I'm looking at the change in my x's and my change in my y's. If you think about distance on a coordinate plane, that change in my x's is going to be how far my x's change, this change in my y's, how far my y's change. When I put that through Pythagoras, I could call this A, I could call this B, and of course C is going to be the distance of this hypotenuse. So instead of having a squared plus b squared equals c squared, I'm just going to have this square root where I'm taking the radical, I'm taking the square root of my a squared plus b squared. So it's important to see these different features of the Pythagorean theorem reflected here in our distance formula. Now here's a little secret. If you're listening, here's a shortcut. You are already finding the change in y and the change in x when you find your slope. So if you have a story like this where you have to fill in a chart, if you notice, I already have my change in x's and my change in y's. I already have my change in x's, my change in y's. I already have my change in x's and my change in y's. We don't really need to be too concerned with negatives because those negatives will square away. If we can simplify the radical, we need to. And then, of course, we need to know the difference between the exact measure as a radical and this estimated value rounded to the nearest hundredth. All right, when we're not given the coordinates, we can get it. Now, slope is sometimes easier to find from your coordinate plane. It's rise over run. So if you're looking for your slope, you can go ahead and rise 1, 2, 3, 4, 5 and run 1, 2, 3, 4, 5, 6, 7, 8. I can count those coordinates on my coordinate plane, and then of course that's what I can use in my distance formula. Remember, if your line is decreasing from left to right, your slope is going to be negative. If you're increasing from left to right, your slope is going to be positive. If your slope is flatter, then it's going to be a fraction between 0 and 1, absolute value wise. And if your slope is greater than 1, it's a little steeper. All right, let's check out the back. When we look at the back of this one, when I graph these coordinates, it's okay that this is 1 off. You can just go ahead and estimate it. I know I'm looking for the centroid, which is the point of concurrency of my medians. My medians are My medians are created from my midpoint to the opposite vertex. Notice when I found the midpoint of this side here, its distance to the opposite vertex is going to be a horizontal line. That makes it real easy for me to find that centroid, remembering that 2/3, 1/3 relationship. I could also find the midpoint of this segment, and I can connect him to the opposite vertex. Notice he goes through the centroid, but it's a little harder to count the distance because it's diagonal. Same thing works here. This centroid is going to be vertical, and then I have that same 2/3, 1/3. Here's 2 blocks, and here's 1, 2, 3, 4 blocks. So we're going to be that 2/3, 1/3 story with our medians. All right, so now we're talking about mid-segments. If I have the midpoints and I connect them, here are the mid-segments. When I want to find the coordinates of the vertices, I want you to think about this mid-segment is going to be parallel to this third side. This mid-segment is parallel to this third side, and this mid-segment parallel to that third side. So it's going to have the same slope. Rise, 1, 2, 3, run, 1, 2. So from that vertex point, rise, 1, 2, 3, run, 1, 2, fall, 1, 2, 3, back, 1, 2. If I repeat that slope counting process for each of these, then I can figure out what my vertices are. Rise 1, back 1, 2, 3, 4. Rise 1, back 1, 2, 3, 4. Fall 1, forward 1, 2, 3, 4. All right, so if you didn't get a chance to do this in class and you need to borrow a compass, please do so now. I chose the in-center. My in-center is created from my angle bisectors. So I went ahead and used my compass to bisect each angle, and then they met at this point of concurrency. It's supposed to be equidistant to the sides of the triangle, so when I took my compass and tried to draw a circle, I was a little off here. If you did the circumcenter, you found the perpendicular bisector. If you found the orthocenter, you found the altitudes. And your centroid would be if you found your midpoints and then connected it to the opposite vertex. All right, so that's it for homework.